Hello everyone, this is a video lecture for Calculus 2, section 11.8, Power Series. Or, I guess, for chapter 11, what we're going to do here is solve for x. Yep. So we're going to solve for x. Basic stuff here, right? We've done this forevers. Our answers, though, must come in the form of a radius of convergence and an interval of convergence. All right, what are those things? So let's say we have a number line, and let's just say that this is the center of our converging whatever we're going to find, solve for x. And there is a radius, like a circle, right? Circles have radius, radii. Anyways, so we have a circle with a radius, and anything within this radius, it would be converging. And so we can do something like this. Maybe there's a square brace on this side, who knows? It kind of depends on the problem. And so that radius r is like a single number, but this parentheses square bracey stuff is an interval, something kind of like we've seen, well, since college algebra. So like intervals of increasing, decreasing constant and all kind of stuff like that. Okay, cool. So that's the goal. We're going to solve for x. So let's do this thing. 11, 8, 0, 0, 4. So we have summation of 5 times negative 1 to the n times x to the n. And they say find the radius of convergence, find the interval of convergence. Okay. So what do we do? Well, what we have here is alternating. And because we have an alternating here, we can take everything else. The limit goes to infinity, that kind of stuff. Okay, so n goes to infinity. You know, I don't write that very often. And they want to know now, is it 0 or not 0, and all that kind of stuff like that. So if you're looking at this guy here, we got n by itself is a linear term. We got this x to the n, which is a, I don't know, a polynomial-y kind of thing. But remember that we're wanting this guy to equal 0 in order to converge, right? This is radius of convergence, interval of convergence, right? Did I say that? Convergence. So we're wanting this to converge. We want this equal to 0. And what are we going to do? We need to solve for x. So x right here must be some kind of number to make this equal to 0. Yep, I'm thinking about it, and yep, you got it. X equals 0 will make that whole thing equal 0. Hey, what's the limit as n goes to infinity of 0? It's 0. Awesome! So you can see that this right here works. I know for sure that we have some type of convergence, even if it's a trivial solution. Let's try some other numbers. I don't know. Let's try like 1. That's a good number to try, all right? And I'm trying particular numbers that make sense. And so we got n, and then I got 1 to the n. And so if you go and plug in infinity, you got an infinity. That one doesn't matter. But you got an infinity, which diverges. So that's no good. X equals 1 does not work. Okay, what about negative 1? So same thing here. Now we have an alternating series, but still, then I have to take this limit stuff. Well, actually, you know what? It's not an alternating series because it's not a series; it's just a limit. Regardless, we got alternating. We still got an infinity, so I don't know, plus or minus infinity still diverges. It's still not going to work. Well, that's a bummer. So 0 works, not 1, not negative 1. What else? So let's try half. I don't know. Let's just try something like that. So limit of, we got 5n to the 1/2 to the n power. Now let's pause for a second. This actually changes the dynamic of the problem. What we have here is a linear term, which is kind of like a polynomial, just power 1. But what we have here is geometric exponential. And I don't often say this as we're going through, but whenever I say exponential, I mean geometric, and whenever I say geometric, I mean exponential. And in this particular section, I combine them almost all the time, so I'm going to do that a lot more. So we have this geometric exponential, which is actually stronger. This guy right here is weaker. So stronger means I really want to look at this guy to know how the limit will end up. And so you do the limit as you go into infinity, and this actually goes to 0, which would converge. So that's cool. This guy works. And of course, the negative versions should also work. What I'm finding is that my answers are between the -1 and 1. Between -1 and 1. So how do I write that with the interval and radius and all that kind of stuff? So interval would be -1 to 1 with the parentheses, and then my radius would just, well, be a 1 because that's how far it is. So on like a number line, we got 0 in the middle, and we got 1, and we have a -1. Well, I did not do that very well at all. There you go. Okay, and so my radius is a 1, blah, 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 blah. So why don't I use the square braces here? Well, you already tested those. And did they work? No. So don't use them. And that's how we know if we're going to use square braces or not. We basically just test the endpoints. And if they don't work, you don't use them. So there you go. Now, one last thing. I used the word weaker and stronger earlier, and I'm going to continue using those for the rest of the section. Stronger just means to me like it's more important. Again, let me remind you of this sequence of comparisons. I don't know, something like that. I'm going to use an X just to make it a little bit more user-friendly here. So you got your logs, you got your roots, you got your linear term, you got your polynomials, you got your exponentials, you got your factorials, and then you got that power tower business or whatever. So I was looking right here, and I was looking right here, and this guy is stronger because he's bigger over time. He's more important. So if he gets to decide what the rest of the series sequence limit stuff ought to be. Okay. Let's do another one. 11, 8, 0, 1, 1. So I've got summation. I got x to the n power divided by 5n minus 1. And again, what's my radius? What's my interval? All that kind of stuff like that. So I think that 0 should work. X equals 0, you plug that in, you got summation of 0. That would converge. So that's awesome. Let's try some other numbers, like, I don't know, 1. So I put a 1 right here. It basically just makes a 1 in the top. And so then what you see is summation of 1 over n. So this is going to summarize down to 1 over n. That's a p-series, which actually this will diverge. So that's not going to work. What about -1? So this one's actually interesting. If you put a -1 here, what you've done is made it an alternating, which in this particular case, you take the limit of the 1 over n, and it does converge. So this one works, this one works, this one doesn't work. I'm hoping that you can already see kind of like a style going on here. Let's try half. I don't know, just trying some other numbers here. So we got now the 1/2, 5n minus 1. Notice that the top here is a geometric, which is stronger than a lot of the other stuff. This would converge because r is, absolute value of r is less than 1 for geometric. So this guy works. So as you're seeing, it's basically my interval is going to be from -1 to 1, centered at 0. But I can't include the 1, but I must include the -1. So I include the -1 with a square brace, but I don't include the +1 because that didn't work. And of course, my radius is just going to be a plain old 1 because I'm centered at 0 and I go from 1 to 1. Next, 11, 8, 0, 1, 3. So summation, this one actually says n equals 2, so it's a little different. Infinity, x to the n plus 2, and then I got 5n factorial. And I'm wondering, does it converge, diverge, and all that kind of stuff? What's the radius of convergence and stuff like that? Well, the top actually is geometric exponential. Actually, no. Actually, yes. Yes, it is. Yeah. I'm sorry. I always mix those guys up. So, yeah. Geometric exponential. X right here is just some kind of number. 2, 5, 1, 0, some -1/2. So that's geometric exponential. So that's pretty good. But the bottom is a factorial, and he is stronger in the bottom. The bottom is stronger. So what I'm getting at is that we're going to have summation of like 1 divided by a big number regardless, which eventually just goes to 0 and will converge. Always. So it always will converge. I don't even have to do the math on this. I just know it's always going to converge because you got a factorial on the bottom. Sorry about that. So my interval then, so like for always converging, is going to be negative infinity to positive infinity. And my radius then is going to be an infinity. This is literally what you're typing into the answer boxes on WebAssign. Okay, 11,8,009. So I've got summation of 4 to the n, x to the n, n to the 5th. What you have in the top here is actually 4n to the n, and that's going to be a geometric again. The bottom is actually a polynomial. So this guy here is actually stronger. He's going to make more decisions than the weaker polynomial. And so what I'm going to do is I'm going to use this as a geometric and see if I know how to make it work. So my absolute value of r must be less than 1. That's the converging for the geometric series stuff. So we have a 4x is less than 1. You move it over, divide by 4. So basically you got absolute value of x is less than 1/4. And that's going to be your answers. You're basically saying my interval is from negative 1/4 to positive 1/4. And there you go. Now I got a question for you. Does it actually work at negative 1/4 and positive 1/4? The only way to know is if I actually plug those in individually. So I'm going to plug this in and see what happens. So I got summation basically of 1 to the n and then n to the 5th. And that's just going to be my p series, but p is equal to 5, so it definitely converges and everybody likes it. I think I messed up a small amount here. Hold on. I flipped it. Hold on. This was the positive. This is the negative. Yeah, I plugged in a positive right here, by the way, because the negative, I should have a negative 1 to the n power. Well, this is alternating, and so then you do the limit as 1 over n go n to the 5th, which also equals 0, and thus this guy also converges. So converge, they converge on both of those points. Therefore, your actual interval should be negative 1/4, positive 1/4, and your radius, because you're centered at 0, is going to be just 1/4. There's your two answers. Let's do another one. 11,8,021. Summation of x minus 4 to the n power, all divided by n to the 4, and then plus 1. On the top, I got a geometric. On the bottom, I got a polynomial. My geometric's going to be stronger, so I want to use that. X minus 4, absolute value less than 1. And so I want to do this my own style. This is something that I, do since like college algebra is what I do this. So I remove the absolute value signs, and I basically, you don't even have to have that. I'm just going to say equals plus or minus 1. So I know they're not the same thing. I'm just kind of getting the idea that you can have a negative or a positive, and so that's why I have a plus or minus 1 there. Well, I'm going to add 4 to both sides, and what happens is that you have minus or plus 1, and then a positive 4. Let me write that a little bit better. And so what are those two numbers going to be? Well, it's 4 minus 1 and 4 plus 1, so a 3 and a 5. And that's going to be your interval here. But do they converge? Do they diverge on those numbers? Like, should I be doing this instead? I don't know. And so what I want to do is I want to test it at those numbers. So x equals 3, I plug it in. And so what I'm going to get is the alternating yet again, which will converge. If I plug in the 5, I get a positive 1 to the n. But it still converges because, again, 1 over n to the 4th. And so therefore, it's p series more than 1 still converges. So they do both converge. Therefore, I'm going to use the 2 square braces. And then my radius is a 1. And you can just look at it here. Oh, zoom in. You can just look at it here and see like, well, where's the center would be a 4, and then what's my radius on either side is a 1. But the other way to see that is just because it's geometric, generally, right there, the plus or minus 1 kind of makes that happen. So, next problem. So, we have 11, 8, 0, 3, 1. So we have a summation n factorial times x, or 3x minus 1 all to the n. Now, this one's a little bit weird because what we have is a factorial, and here this is a geometric exponential. And this guy's definitely stronger. This one's much stronger. And he's going to dominate the entire problem. Because he's also in the numerator, I would say, diverges. And that's pretty much it, yeah. But what if, just what if I set x equal to 1/3? What if? So then I have 3 times 1/3 is 1. 1 minus 1 is 0. The whole thing times 0 should be 0, and it converges. So this is kind of like a special case. I'm basically trying and forcing it to make the trivial solution. Summation of 0 is 0. Great job. Converges. So, and it does exist here. So what should we do? How should we approach this answer? I'm saying that if I plug a 1/3 in right here, it does converge, but anywhere else it's going to diverge. How do I say that, Well, your radius of convergence, this is just strange, very strange, is actually equal to 0. And your interval of convergence is, with curlies, 1/3. What this is trying to say, like together, is that it's only x equals 1/3 converges and nothing else. Like only that single number. Radius 0 is saying that no other numbers will work besides this one number. Like that's it. You're thinking, oh, well, I found one number, so r equals 1. Well, no, because if r equals 1, you're going from negative 2/3 up to positive 4/3, and none of those are working. You don't want to do that. So I'm saying no other numbers, only the 1/3. And that's why you got the curlies. It's saying only the 1/3. Of course, I'm trying to do the weird problems as well. I don't just do easy problems here. So that's why I did that problem. We got summation. I got x to the n divided by 1 times 3 times 5 times 7 times all the way to 2n minus 1. Something kind of like that. And they say, okay, find out where it's converging, diverging, and all that kind of stuff. Well, on the top here, what we have is an exponential geometric kind of situation. And what we have in the bottom is a factorial. Kinda. It's the odds, but it's still basically a factorial-ish kind of thing. Well, in my mind, I see that we have factorial stronger. And this is weaker. And so again, what I mean by that, I mean we got like some kind of number divided by a really, really big number. And that is basically going to go to 1 over infinity, which will go to 0, and therefore it converges, and all that kind of stuff. That's at least my first thoughts. But does it? Like, is that my answer? So what I want to do is I want to do ratio test. We do have to use it once in a while. So to do that, I take the next term, and of course all this stuff here. And I'm going to just go ahead and tack on an additional term. You can see that I said, oh, well, n plus 1, the 2, then it'd be the next odd number, basically. And then we have this original down here. You know, I'm going to change this a little bit, this guy a little bit. There you go. That's a little bit better because it'll cancel. 1, 3, 5, 2n minus 1. All right. Cancel. And so what I'm left with now is x in the top and 2n plus 1 in the bottom. and this guy here has got to be less than 1 in order for it to converge. So I'm wondering what numbers here will make that work. Well, I mean, what if I plug in a 0? Will that work? Yeah, 0 works. What if I'm plugging a 1? If I plug in a 1, will it still go, well, what's the limit? It actually goes to 0, so this also works. What about like 100? Well, let's just do 1,000. Let's just do 10,000. 10,000. Yeah, it's still going to work. What about a negative 10,000? Yeah, it's still going to work. And it's going to work everywhere. Now, the only thing that would make this change is if you said something weird like x equals n, and then all of a sudden your n's will cancel and you got to do some other weirdness. In fact, I think you might even have to do 2n for it to actually do that. But we don't say x is equal to an n because that's not a single number. I need a number. Give me a number. Solve for x. And if you were just to say, well, x is some kind of number, that's not going to cut it. You know, I need a single number, solve for x, give me what it is. And so you can't do that. I'm looking for a number. It works. Everything works. And so I'm going to say everything works. But how do I say that with my interval and radius and all that kind of stuff here? So I'm going to go negative infinity, positive infinity, and I'm going to just do the infinity here as well. I think we actually already had one of those, didn't we? I think so. Yeah, I did something funny on my paper, but that's good enough. Okay, cool. Next one is 118045, and this is actually the last one I have. So R1 is equal to 2. I have R2 is equal to 1. No, I'm playing 3. It's just kind of funny. Why would they mix it up? And so they're wanting to know where they both converge. Like, what's the radius of convergence for both of them together? Added, subtracted, multiplied, something like that. So over here we got 0, 1, 2, 1, 2. And we got this kind of 2 business here. And then on this side, we got a 3 business. There's 0, 1, 2, and 3, 1, 2, and 3. Something kind of like that. And so I'm going to overlay them on top of one another. And I'm going to use 2 different colors so you can see. So there's my 0, 1, 2, 1, 2. So there's my red. And then I have my blue, which would be at the 3 mark, like that. And I want to know where they both will converge. And they should both converge right here. Like, see how in this magenta here, this red is converging, the blue is converging, we're cool. But like if I put something right here, the blue is converging but not the red. And the same thing goes over there, and the same thing way out here, nothing is converging. So only on the inside here, and so I'm going to actually say where they both going to converge, and it's that r equals 2 business. It's the smaller number. I mean, just there. On this problem, just type in the smaller number, you're done. Yeah, I know, but now I told you why. So that's it. That's all I got. Thank you very much. Have a great day.